Welcome viewers. In this video we'll see the relationship between two-port network parameter H parameter in terms of ABCD parameters. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Two-port network parameter. There are four type of two-port network parameters available. First one is the Z parameter, open circuit impedance parameter. Then Y parameter, short circuit admittance parameter. Third one is hybrid parameter, combination of first and second, impedance and admittance parameters. The fourth one is ABCD transmission parameters. So this separate video available for these four parameters. So in this video we are going to see how we are expressing H parameter in terms of ABCD parameters. This hybrid parameter is a general equation. V1 and I2, that is 1 refers input port, 2 refers output port. So input port voltage and output port current are expressed in terms of input port current and output port voltage. So here both current and voltages are available, so it is called a hybrid parameter. So this H11, H12, H21, H22 is the hybrid parameters. We'll take this equation 1 and 2. Similarly, ABCD parameters, this transmission parameters. This is mainly used to design the transmission line. We can use this ABCD parameter. That's why it's called a transmission parameter. Here V1 and I1, input port voltage and input port current are expressed in terms of output port voltage and output port current. A, B, C, D are the parameters. We will take this equation number 3 and 4. Now we will see how to get the relationship between these two parameters. First, consider the equation number 4. We are going to modify the equation number 4. We can modify the equation 4. This equation 4 is nothing but I1 equal to CV2 minus DI2. Brought this CV2 in the left hand side so that it become negative. I1 minus CV2 equal to minus DI2. Here already negative is available. Now rearrange this. Brought this term in the left hand side, brought this term in the right hand side. Just rewrite. It's rearranged. Minus di2 equal to I1 minus CV2. Brought this minus d in the denominator of the right hand side. So that what happened here? Minus 1 by d I1. Here one minus is there. Here also minus is. So it become plus c by d V2. So this d is brought in the denominator. We'll take this equation number 5. This is I2. We got the expression for I2. Minus 1 by d I1 plus c by d V2. We'll take equation 5. Now we are going to substitute this I2 value in equation 3. What is equation 3? V1 equal to A V2 minus VI2. So this I2 we are going to replace from this equation number 5. Now we'll see how we are substituting and how we are simplifying the expression. So this I2 is replaced by the term from the equation 5. Now multiply this minus b inside. So already here minus is there, here also one minus. So b by d I1 minus, this minus is there, so it's minus. Already c by d is there, you have to multiply with b. So bc divided by d into v2, right? Now it is multiplied, minus b is multiplied. So here the first term v2 available and third term also v2 available. So we can take v2 commonly between first and third term. So first term we have a is available. And third term we have minus b by bc divided by d. So a minus bc divided by d into v2. This is the second term. Right. Now we'll take the LCM. This d is taken as LCM. Here no term is available, so it is multiplied. AD minus BC divided by D into V2. This AD minus BC can be written as determinant of the transmission matrix. So shortly we can write delta T. That is nothing but AD minus BC. We'll take this equation number 6. We got the expression for V1. In equation 5, I2. Now it is V1. B by D I1 plus delta T divided by D into V2. We'll take equation 6. Now we'll see how to get the relationship between this H parameter and ABCD parameter. Now we are going to compare the equation 5 and 6 what we rearranged with equation 1 and 2, so that we can get the relation between H parameter and ABCD parameter. So this is the equation 5 what we rearranged, minus 1 by d I1 plus C by d V2. Similarly, this is equation 2 V1 equal to B by d I1 plus delta T divided by d into V2. So this is equation 1 and 2, that is hybrid parameter general equation. V1 equal to H11 I1 plus H12 V2. I2 equal to H21 I2 plus H22 V2. Now we can compare this both the equation, because here we have V1 I2, here also V1 I2, so that we can compare the coefficient of this equation. Equation 1 is compared with equation 6 because it is V1. We are going to compare equation 1 and 6 because both are V1. Here the coefficient of I1 is H11. Here coefficient of I1 is B by D. So both are equal. H11 equal to B by D. Right? Similarly, the coefficient of V2 is H12. Here coefficient of V2 is delta T divided by D. So both are equal. H12 equal to delta T divided by D. Right. Now we'll compare equation 2 and equation 5. So because both are I2. Here coefficient of I1 is H21. Here coefficient of I1 is minus 1 by D. So both are equal. H21 equal to minus 1 by D. Similarly here coefficient of V2 is H22. Here coefficient of V2 is C by D. So both are equal. H22 equal to C by D. So now we got the relationship between H and ABCD parameters. So all these hybrid parameters are expressed in terms of the ABCD parameters, right? So we are compared equation 1 and 6. So H11 is this term, H12 is this term. Similarly, we compared equation 2 and 5. H21 is this term, H22 is this term. So based on that, we got the relationship. H11 is B by D, H12 is delta T divided by D, H21 is minus 1 by D, H22 is C by D. So on all the time the denominator is D only, right? So this is the relation between H parameter in terms of ABCD parameters. So in this video we discussed what are the two-port network parameters available, 4 type of parameters. Then we discussed the general equation of H parameter and ABCD parameter. Then we rearranged the equation so that we got the new equation 5 and 6 for the expression of V1 and I2. That is compared with equation 1 and 2. So that we got the relation between H parameter and ABCD parameters. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.